In this video, I just want to do a little more review on some different things with derivatives. This first one, finding dy dx, I think the first thing I would do is I would rewrite this as y equals 5x minus 4 to the 1/2 power. Okay, and then it becomes just power rule with chain rule. So the derivative, if I can kind of just work it up here, dy dx is equal to, I bring the 1/2 up front, I leave the inside alone, so it becomes 5x minus 4. Now it's to the negative 1/2, and then multiplied by the derivative of the inside, which is 5. Okay, so the calculus portion of this is now done. At this point, I'm going to simplify a little bit. You'll notice I have this 1/2 times 5, so 5 halves. 5x minus 4 is raised to the negative 1/2. Remember, the negative means it will go in the denominator. And as much as we don't really worry about simplifying for the AP exam, like if this were free response, of course I would be done. Negative exponents are kind of ugly to look at, so I'm going to rewrite this with the 5 in the numerator, the 2 in the denominator, and you could certainly just write 5x minus 4 to the negative 1/2, or you could put it back and say, well, 1/2 power is a root, so there it is. Okay, the next one, I'm going to rewrite this as 7 multiplied by 4x plus 1 to the negative 2nd. Okay, so kind of the same idea. I'm going to use power and chain rule instead of, in this case, instead of quotient rule. Now, the reason that works so well is because this numerator is a constant. If this were 7x, so it were a function with a variable, I don't know that I would write it this way, 7x times this, because then it would just be product rule with a negative exponent, and that doesn't help me. In fact, that might make things worse. So, it works great because here the numerator is simply 7. So look for that. If it's a function, go for quotient rule. Okay. All right. So same idea here. Dy dx equals, so 7 multiplied by negative 2, I have negative 14. I'll leave that inside alone. Be careful here when you drop the power. Remember, it drops down to negative 3 multiplied by 4. So negative 14 times 4 is negative 56. And we'll put that 4x plus 1 in the denominator. And now it's to the 3rd. Okay, so there are two derivatives. Finally, it says if xy squared plus 2xy equals 8, then what, at the point 1, 2, what is the derivative? So we've got some implicit, and here it's actually saying what is the slope at the point 1, 2. So the first thing, of course, we need is the derivative. So you'll notice it is implicit. We're going to need some product rule here. So let's start with that. We've got first times derivative of the second plus second times derivative of the first, which of course is just 1. This next portion, you've got some choices here. You could say, well, I'm going to kind of leave the 2 out front as a constant, and I'm going to just kind of think of x, y as a product like first and second. Or you could maybe think about it this way, and maybe I'll do it this way simply to be a little bit different than that. Think about it like this, like 2x is your first term and y is your second. So you could say first times derivative of the second plus second times derivative of the first. And of course, the derivative of 8 is 0. Now, we want to move things. Dy dx stuff on one side and non-dy dx stuff on the other. I am going to subtract a y squared from this side and subtract a 2y, like that. And now you'll notice I have these two terms with dy dx, like that. So if I factored that out, I would have 2xy plus 2x equals negative y squared minus 2y. So dividing both sides, there is my derivative. Okay, so now let's actually plug that point in because it said find the actual point. Or I'm sorry, find the slope at the point. So I've got negative 2 squared, so I've got negative 4 minus 2 times 2, so 4 over 2 times 1 times 2, so 4 plus 2 times 1, which is 2. So I've got negative 8 over 6, which reduces to negative 4/3. So there is my slope.